Hi everyone, this is Mrs. G.A. and today we're going to talk about the trigonometric functions of angles. Alright, so the first thing we're going to talk about is how to determine the sign of your trigonometric function based on quadrant. So remember, this is called quadrant 1, this is called quadrant 2, quadrant 3, and quadrant 4. So there's a little trick that people use to remember which functions are positive in each quadrant, and it goes like this. All students take calculus, ASTC, so that's how I always remember it. A stands for all. So in quadrant 1, all of your trig functions are positive. In quadrant 2, S stands for sine. So only sine and its reciprocal function cosecant are positive. In quadrant 3, T stands for tangent. So tangent and cotangent, its reciprocal function, are positive. And in quadrant 4, only cosine and its reciprocal secant are positive. So maybe on the top of your paper when you're doing the homework or on the top of a test or quiz, you want to quickly draw out this little ASTC, and it will remind you which functions are positive in each given quadrant. So that means in quadrant 2, cosine and tangent are negative. In quadrant 3, sine and cosine are negative. And in quadrant 4, sine and tangent are negative. All right, so let's see if we can find the 5 other trigonometric ratios given 2 pieces of information. So here we are told that the sine of theta is 3/5, and then we're told that we are in quadrant 2. So I'm actually going to draw a little picture of this. So we're going to have some angle that looks like this. So it's in quadrant 2. And we'll use this as our angle, so theta. So the sine of theta is 3/5, so that means this is 3 and this is 5. Remember, opposite over hypotenuse. Now, if we solve for this last leg using the Pythagorean theorem, we would get 4, but since we are in quadrant 2 and we're moving to the left, we're going to label this -4. So you can see when I start, again, we're told this one, when I start to find the 5 other trig ratios, let's start with cosine. So we know that since we're in quadrant 2, cosine should be negative, and here's why. It's because we're moving to the left. So the cosine of theta would be -4/5. Tangent should also be negative, and according to our triangle, it's -3/4. And then cosecant is the reciprocal of sine, so 5/3. Secant is the reciprocal of cosine, so -5/4, and then cotangent is the reciprocal, so -4/3. So again, either you can just find these angles and then make everything except for sine and cosecant negative, or you can actually draw a little triangle and then notice, hey, if we're in quadrant 2, this leg is going to be negative because we're moving to the left. All right, let's try this next one. Here, we are told that the tangent of theta is -4, and we're told that cosine of theta is essentially positive. Greater than 0 means positive. So we need to do a little bit of critical thinking and say, okay, in what quadrant is tangent negative but cosine positive? Remember, the only time where cosine is the only angle that's positive is in quadrant 4. So I know that it must be somewhere in quadrant 4. So let's turn this into a right triangle like this, and then we'll call this our angle. We can use this as our angle. And if the tangent is -4, we know that we could call this -4, and then this would be +1. So again, we know that this is -4/1, and we know that the negative value must be this leg because we are in quadrant 4, and quadrant 4 has a positive x value and a negative y value. So we're going to take a moment and find the length of our hypotenuse using the Pythagorean theorem. So our hypotenuse length is going to be the square root of -4 squared plus 1 squared. So C is going to be the square root of 17. And now we can find all of the remaining trigonometric functions. So sine of theta is going to be negative 4 over root 17, which is negative 4 root 17 over 17. Cosecant, its reciprocal, is going to be negative root 17 over 4. Cosine is going to be 1 over root 17. And that means if we rationalize, it's root 17 over 17. Its reciprocal, secant, will just be root 17. Notice again, you can see in our triangle that the value ends up positive, and that's exactly what we wanted. Cosine needs to be greater than 0. And last, tangent we are given. So the reciprocal of that is negative 1 over 4. And there you have it. Okay, so now we're going to talk about probably one of the most important concepts in terms of helping us evaluate an expression, and that would be what's called the reference angle. So we're going to be working with the reference angle all the time. This is a very important thing to be able to find. So the reference angle is the angular distance to the closest x-axis. So if you're given an angle somewhere in quadrant 1, our reference angle is right here. So notice it's the distance to our closest x-axis. And we can label this theta prime. That's how you can denote a reference angle. Let's say we have some angle in quadrant 2. Again, it's the reference angle is the distance to the closest x-axis. I know that it looks closer to the y-axis, but it doesn't matter. This is our reference angle, theta prime. And then let's say we have something in quadrant 3. Our reference angle would be right here. And if we have something in quadrant 4, our reference angle would be right here. So again, it's always the distance to the closest x-axis. And one other thing to note, for the reference angle, we always consider the reference angle to be positive. Okay, so now we're going to talk about how to evaluate the trig function of an angle, and this is all going to be based around the reference angle. So the first thing you're going to do is determine what the reference angle is. And it turns out if you know the reference angle, you can really just use this angle to evaluate. And our reference angle is always going to be also something between 0 and 90 degrees, so it's nice and easy to evaluate. Once you know the reference angle, you do need to make sure that you look at the quadrant and which function you're using to determine the sign of your answer. So you should denote from the beginning whether your answer will be positive or negative, and then you simply evaluate it based on, like I said, the reference angle. Okay, so we're going to be using the reference angle to evaluate the following expressions. So the first one is the cosine of 45 degrees. So we know that our reference angle is 45 degrees, right? If we have an angle in quadrant 1, that angle is actually going to be the same as our reference angle. So the reference angle is 45 degrees. We are in quadrant 1. And we know that in quadrant 1, all of our functions are positive, so we know that our answer will be positive. And now all we need to do is say, hey, what's the cosine of 45 degrees? And the answer is root 2 over 2. So this is something that hopefully you have memorized, but let's say you don't. So let's look at the picture we just drew. We can always turn this into a right triangle, and then we're going to work with our reference angle, again, which was 45. Here you'll see that we have a 45, 45, 90. So you can mark this up using the values we know, 1, 1, root 2, and then you can say, okay, cosine is 1 over root 2, which is root 2 over 2. All right, let's try 7 pi over 6. So when something is in radians, it's really easy to find the reference angle. Pretty much anything over 6, the reference angle is going to be pi over 6, which is also 30 degrees. Now, 7 pi over 6 is in quadrant 3. And we know that in quadrant 3, let me draw this little picture again. A, S, T, C, we know in quadrant 3 only tangent is positive. So if I'm evaluating a sine function, I know that my answer will be negative. And then we ask ourselves, okay, what is the sine of pi over 6? What's the sine of 30 degrees? And that's 1/2, so our answer is negative 1/2. If you have those values memorized, it's really useful. If not, we can sketch a picture. So we know that 7 pi over 6 is right here, down in quadrant 3. But again, all we really care about is our reference angle, which is pi over 6, or 30 degrees. So if we turn this into a right triangle, like this, we can mark up our angle, or our triangle, 1, 2, root 3, and then we need to be careful to adjust our negatives. This is going down, so it's negative. This is going left, so it's negative. And then we can work from this angle and say, okay, sine is opposite over hypotenuse, negative 1 over 2. So if you don't have your values memorized, you can always draw a picture and use your special right triangles to help. All right, now let's talk about the tangent of 5 pi over 3. So our reference angle is pi over 3, which is 60 degrees. 5 pi over 3 is in quadrant 4. And we know in quadrant 4 only cosine is positive, which means this value should be negative. So then all we need to do is ask ourselves, hey, what's the tangent of pi over 3? It's going to be root 3, and then we just make our answer negative. Now again, if you don't have your quadrant 1 angles memorized, we can sketch a little picture. So 5 pi over 3, again, is somewhere in quadrant 4. Our reference angle is pi over 3, which is 60 degrees. And then we can turn this into a right triangle and mark it up. This is going to be 1, 2, negative root 3. Right? 1 is always opposite our 30-degree angle. And so we're working with the 60-degree angle, and we're finding the tangent, so opposite over adjacent, negative root 3 over 1. Okay, last is the cosine of 360 degrees. So this one is not in one of our quadrants, it's actually on one of our axes, so it's a little bit different. We know that it's right here, and it's what happens after a full rotation. So instead of using our reference angle, because it's on the actual x-axis, here I'm going to use the unit circle coordinate to evaluate this one. So if you think to your unit circle, the coordinate for 360 is 1, 0. And we are evaluating a cosine function, so we know cosine is the x value from our coordinate. So the cosine of 360 degrees is simply 1. All right, go ahead and pause the video and see if you can give these 4 problems a try. So remember, try finding the reference angle, and then determine the sine of your answer, and then evaluate from there. Okay, let's look at the first one. So here we have 270 degrees, which is on our y-axis. So I take the coordinate from the unit circle, which is 0, negative 1, and it's going to be the x value of our coordinate. 3 pi over 4 is an angle in quadrant 2, so we know our answer will be positive because sine is positive in quadrant 2. Our reference angle is 45, so maybe you just know, well, the sine of 45 degrees is root 2 over 2. If not, draw your right triangle and fill out your special right triangle, opposite over hypotenuse. 5 pi over 6 is also in quadrant 2, so we know that our answer will be negative because we're working with tangent. Our reference angle is pi over 6, so if you know that by memory, tangent of pi over 6 is root 3 over 3, all you have to do is put a negative out front. Or you can draw a special right triangle and mark it up and do opposite over adjacent. And last, 120 degrees has a reference angle of 60. It's in quadrant 2, so it's going to be a positive answer. So here, we should know that the sine of 60 is root 3 over 2, or you can draw a triangle to help you determine that measurement. Okay, so now we're going to do the same process, but we're going to work with angles that are a little bit trickier. So this first one, we have tangent of negative 300 degrees. So this is not one that's as easy for us to work with. So the first thing I'm going to do is find a coterminal angle for negative 300. That's positive. And the way we do that is by adding a full rotation, which is 360. So tangent of negative 300 is actually exactly the same as the tangent of 60 degrees. So maybe you just know this one by memory. You should know that the tangent of 60 degrees is square root of 3. If you don't, that's okay. We can draw a picture. We know that 60 degrees is in quadrant 1. Our reference angle is 60. We can turn it into a little right triangle and mark up our triangle. 1, 2, root 3. So the tangent of 60 degrees is root 3 over 1. Okay, let's look at this next one. Here we have the tangent of 23 pi over 6. So the first thing I'm going to do is find a smaller coterminal angle of 23 pi over 6. So I'm actually going to subtract a full rotation, which is 2 pi. Or 12 pi over 6, and we get 11 pi over 6. So this is an angle that I'm familiar with from our unit circle, so it's a little bit easier for us to work with. So again, I could look at this and I could say, okay, my reference angle is pi over 6. We're in quadrant 4, so I know that our answer is going to be negative, because sine is negative in quadrant 4. And then I say, okay, what's the sine of pi over 6? 1/2, and then all you need to do is make it negative. Again, if you don't have those values memorized, it might help to draw a little picture. So again, 11 pi over 6 is right here going around, but all we really care about is our reference angle, which is 30 degrees, same as pi over 6. Mark up your triangle. Negative 1 to root 3, and then sine is opposite over hypotenuse, so negative 1/2. All right, last we have cosine of negative 7 pi over 4. So I'm going to find a positive coterminal angle by adding 2 pi, which is also 8 pi over 4. So it's just simply positive pi over 4. So the cosine of positive pi over 4, hopefully we know, is root 2 over 2. If you don't have those memorized, let's go draw a picture. We're in quadrant 1. Our reference angle is pi over 4, which is 45 degrees. If you make a quick little special right triangle, you can do adjacent over hypotenuse and you get root 2 over 2. So again, I would really recommend having your quadrant 1 angles memorized, so sine, cosine, tangent of 30, 45, and 60 degrees. But if not, you can always draw a picture, but you will need to know how to use a special right triangle. Okay, here's your last 3 to try. Go ahead and pause the video and give it a shot. We'll check our answers in just a few seconds. Okay, so here, the first thing I did was I rewrote 495 degrees as 135 degrees. Just subtract 360 to find a coterminal angle. So 135, your reference angle is 45. It's in quadrant 2, so it's negative. And cosine of 45 degrees is root 2 over 2. Or draw a picture and make a special right triangle. Here, 11 pi over 2, you're going to have to actually subtract 2 full cycles to get to 3 pi over 2, which is down here. Remember, for anything on our axis, I would use the coordinate from the unit circle. So our coordinate is 0, negative 1. Sine is the y value, so our answer is negative 1. And here, negative 540, if you add 2 full rotations, you see that negative 540 is the same as positive 180. So we're right here. The coordinate here is negative 1, 0, and cosine tells us to use the x value of our coordinate. So negative 1 is our answer. All right, that is all for today's video. Thank you so much for watching.